Hey guys, in today's class, we will talk about water and water properties. We will learn about the main properties of water and why is water so essential and so special for life. Water is the biological medium on Earth, exists naturally in an environment in all three physical states of matter. Also, about 75% of our cells and our bodies are made of water. You may already know some properties of water. For example, water boils at 212 degrees and freezes at 32 degrees. It is nearly colorless and it is tasteless and odorless. Regarding the molecular structure of water, it is composed of two hydrogen atoms and one oxygen atom in the center. The atoms are covalently bonded and form a 105-degree angle, looking like a V shape. There are several properties of water that facilitate life. They are polarity, cohesion and adhesion, the physical states of matter, density, heat capacity, solvent, and pH. Let's examine each of them in more detail. Polarity means the separation of charges in a molecule. Water molecule is polar because the charges are unevenly distributed. If you look at the molecule, you can see that the oxygen atom has 8 electrons on the outer orbit, and the hydrogens have only 1. This means that the oxygen side is more negative, and the hydrogen side is more positive. The oxygen, being more negative, pulls the molecule's charge towards his side, creating a partial negative charge around him. In chemistry, polar substances will dissolve other polar substances, and also some ionic compounds. How does this happen? The negative pole of water, the oxygen, is attracted to the positive pole of another molecule, and vice versa. When water molecules are close enough, they can perform intermolecular bonds. These are very strong bonds that give water some cool properties. Remember, intermolecular bonds are those bonds between molecules. Non-polar molecules, on the other hand, will not experience hydrogen bonding. Related to hydrogen bonds are two properties of water: cohesion and adhesion. Cohesion is the tendency for the same kind of particles to be attracted to one another. Particles are more strongly attracted to the identical particles. Adhesion is when forces of attraction exist between different types of particles. Water is adhesive to any substance with which it can form hydrogen bonds, like particles of a container or surface. Cohesion and adhesion are important in soil and relations between plant and water for nutrient transport in plants. Another property is the fact that water exists in all three physical states: gas, liquid, and solid. And not only that, it can change between them with the right environmental conditions. For example, ice can melt to liquid, which then can evaporate. Also, if a lot of energy is given, it can go directly from ice to vapor state, and this is called sublimation. The opposite is also true. Water vapor can condense to liquid state and then freeze, or it can freeze directly, and this is called deposition. Also here, the hydrogen bonding plays a special role. Solid state is characterized by molecules being very close together. Water molecules in ice are rearranged in an ordered and hexagonal shape, like a honeycomb, just like what we see in snowflakes. This is because it is the best way that those molecules find to be close enough so that the molecules are the closest to each other but not that close, so not to generate repulsions between the charges. When we provide energy through heat, ice starts to melt and the hexagonal structure starts to collapse, so the intermolecular bonds, they start to break. Now, have you wondered why does ice float? This actually brings me to another property of water, density. Density is a measure of how much mass a substance has per volume. Like most liquids, the density of water increases as they get cooler because particles come very close. However, water's density is maximum when it reaches about 39 degrees, and then it decreases again to a minimum when it is frozen. That means that at 32 degrees, when the water freezes, the density of water is lower than it was in the liquid state at 39 degrees. This has to do with the hydrogen bonds and the formation of the honeycomb structure I told you before. On the other hand, it has to do with the density property. Now, have you wondered why oceans don't freeze? The answer to this question is on another property of water, heat capacity. Heat capacity refers to the amount of energy needed to increase the temperature of something in 1 degree Celsius. Water has a really high heat capacity compared to many other substances, meaning that it takes a lot of energy, and time for that matter, for water to change its temperature, either increase or decrease. Water can absorb or release large amounts of heat with little change in its actual temperature. The reason why this happens is the strength of the hydrogen intermolecular bonds that water can make. They are really strong. The resistance to sudden temperature changes makes water an excellent habitat. Overall, there are no wide temperature fluctuations, and it can be used to regulate the internal temperature of our bodies, so we don't burn or don't cool down too much. The same applies to the regulation of the temperature in the oceans and lakes. This property, the heat capacity, is also used for cooking our pasta, for example, to freeze our food, to cool down the air with air conditioning systems, in power plants to generate energy, and also in agriculture. People flood their crops when the weather is too hot or too dry. Another important property is the fact that water is the solvent of life. It can dissolve more substances than any other substance, even large molecules like proteins. Besides regulating the body temperature, water is used to dissolve and transport nutrients, not only through our bodies, but also from in and out of the cells. It is produced and participates in metabolic reactions. It is used as lubricant and shock absorber, and maintains the blood volume and pressure. It is also important in geology because water is used to transport substances through the earth. Another very important property of water is pH. You definitely heard about pH before, but maybe you don't know what it actually means. pH refers to the acidity or basicity of a substance. It also describes the concentration of certain ions in solution. These ions are called hydronium ions and happen when one hydrogen from a water molecule momentaneously shifts to another water molecule. So the receiving water molecule becomes H3O plus ion, meaning it has a positive charge, and the other water molecule becomes simply OH minus, meaning it has a negative charge. So a solution with abundance of H3O plus ions are called acids, and solutions with abundance of OH minus ions, or few H3O plus ions are called bases. The pH of substances can range from 1 to 14, where the middle, 7, is when a substance is called neutral. Now that you understand better the concept of pH, let's see why it is critical for life. Well, basically, our body is very sensitive machinery and can only function within a very tight range of pHs, around 7.3 and 7.4. This range controls the availability of nutrients and their intake, the biological functions, microbial activity, and the overall behavior of chemicals in our body. And water helps this a lot because it has a pH around 7. So, when we eat different substances that have varied pHs, our body must be able to regulate this, and water is used to regulate it in our bodies. But not only in our bodies, also in the oceans. You see, seawater absorbs carbon dioxide from the atmosphere, CO2, which is then converted in carbonic acid, H2CO3. As the name says, it is an acid, and the accumulation of this substance could change the pH of the ocean. However, this acid is quickly decomposed in bicarbonate, HCO3-, and carbonate ions, CO3-, and transformed in other substances that do not affect the pH of the ocean. How does this happen? Well, on the one hand, the carbonate ions react with calcium ions, Ca2+, which are in excess in seawater, and form calcium carbonate, CaCO3, which is the material out of which the shells of mussels, the skeletons of corals, and the exoskeleton of some microalgae are made of. So it's perfect balance. And remember, guys, sanitize your hands, put on a face mask, and keep social distance.